transistor. A transistor is a semiconductor device used to amplify or switch electrical signal and power. The transistor is one of the basic building blocks of modern electronics. It is composed of semiconductor material, usually with at least 3 terminals for a connection to an electronic circuit. A voltage or current applied to one pair or the transistor terminal control the current through another pair of terminals. Because the controller output power can be higher than the controlling input power, a transistor can amplify a signal. Some transistors are packaged individually, but many more in miniature form are found embedded in integrated circuit. Disadvantage of transistor: it has reverse blocking capacity is very low. It can be damaged due to the thermal runaway or second breakdown. Manufacturing techniques are very complex and require a clean room environment. Due to its small size, it is difficult to trace bug faulty one due to failure. Moreover, it is very difficult to unsolder and replace new one. Power transistor cannot be operating satisfactorily above switching frequency of around 50 kHz. Function transistor: a transistor can act as a switch or gate for electronic signal, opening and closing an electronic gate many times per second. It ensures the circuit is on if the current is flowing and switch off if it is. Transistors are used in complex switching circuits that comprise all modern telecommunication systems. Circuits also offer very high switch speed, such as 100 or GHz or more than 100 billion on and off cycle per second. Transistors can be combined to form a logic gate which compare multiple input current to provide a different output. Computer with logic gate can make simple decisions using Boolean algebra. These techniques are the foundation of modern day computing and computer program. Advantage of transistor: it is used for fast switching application, smaller mechanical sensitivity. It is used as a current control current gain. It is available at very low cost. It is very small in size. Fast switching: it has a longer life, low operating voltage for greater safety, lower cost and tighter clearance. Extremely long life. The transistor is very easy to turn on and turn off the power transistor. Thank you.
Field effect transistor. What is field effect transistor? A field effect transistor is a 3-terminal active semiconductor device in which an electric field produced by the input voltage regulates the output current. Function of FET. FET are extensively used in integrated circuits due to their compact size and significantly lower power consumption. Apart from that, FETs are also used in high-power switching applications as voltage variable resistor in operation amplifier and tone control. For mixers operation on FM and TV receiver and in logic circuit. 4 terminal of FET. First, source. Source is the terminal through which the majority charge carriers are entered in the FET. Second, gate. The gate terminal is formed by diffusion of an N-type semiconductor with a P-type semiconductor. This creates a heavily doped PN junction region that controls the flow of the carrier from source to drain. Third is drain. Drain is the terminal through which the majority charge carriers exist from the FET. The last one is body. This is the foundation upon which the FET is constructed. Since it is internally connected to the source pane in discrete applications, its effect can be completely disregarded. However, because it will be shared by several transistors in integrated circuit, this pane will normally be connected to the most negative power supply in an NMOS circuit.
Misfet field effect transistor Misfet. The meter-insulated semiconductor field effect transistor Misfet is a type of field effect transistor FET that use a metal-insulated semiconductor MIS structure as the gate of the transistor. This structure allows for high input impedance and low leakage current, making the Misfet a popular choice for use in digital and analog circuit. The Misfet can be used as a switch or a voltage control resistor and is commonly used in electronic devices such as computer, mobile phone, and other electronic devices. Basic operation of Misfet. When a positive voltage is applied to gate relative to the substrate which is connected to the source, in this case, positive charges are in effect deposited on the gate metal. In response, negative charges are induced in the underlying C by the information of a depletion region and a thin surface region containing mobile electron. This induced electron form the channel of the FET and allow current to flow from drain to source.
Okay, then we go to Mosfet. Mosfet, why Mosfet? Mosfet are particularly useful in amplifiers due to their input impedance being nearly infinite, which allows the amplifier to capture almost all the incoming signal. The main advantage is that it requires almost no input current to control the load current, and that's why we choose Mosfet over BJT. And Mosfet have two different types, and one of these is depletion mode. The transistor requires the gate source voltage or VGS to switch the device off. The depletion mode Mosfet is equivalent to a normally closed switch. And 2. Enhancement mode. The transistor requires a gate source voltage VGS to switch the device on. The enhancement mode Mosfet is equivalent to a normally open switch. Now, with respect to the working principle, Mosfet is classified as follows: 1. P-channel depletion Mosfet, 2. P-channel enhancement Mosfet, 3. N-channel depletion Mosfet, and 4. N-channel enhancement Mosfet. And we only take a 2-channel Mosfet, and one of this is P-channel Mosfet. P-channel Mosfet is the drain and source are heavily doped P-plus region and the substrate is in N-type. The current flows due to the flow of positively charged holes, and that's why known as a P-channel Mosfet. When we apply negative gate voltage, the electron present beneath the oxide layer experience repulsive force and are punched downwards into the substrate. The depletion region is populated by the bound positive charge which are associated with the donor atoms. The negative gate voltage also attract holes from the P plus source and drain region into the channel region. And the lastly is N-channel Mosfet. N-channel Mosfet is the drain and source are heavily doped N plus region and the substrate is P-type. The current flows due to the flow and of negatively charged electrons, and that's why known as N-channel Mosfet. And then when we apply the positive gate voltage, the holes present beneath the oxide layer experience repulsive force and the holes are pushed downwards into the bound negative charge which are associated with the acceptor atoms. The positive gate voltage also attracts electron from the N plus source and the drain region into the channel. Thus, an electron each channel is formed.
Now go to the Mesfet. What is Mesfet? Mesfet is the acronym of Metal Semiconductor Field Effect Transistor. It is similar to GFET, but the difference is instead of PN junction inject metal semiconductor, Schottky junction in use, controlled by the gate terminal and the depletion region below. So, this is Mesfet symbol, P channel and then N channel. So, in the depletion mode, Mesfet is normally on, and in the enhancement mode, Mesfet is normally off. In the depletion mode, the size of the depletion layer increase, and thus, in the symbol gate terminal in the depletion mode is thinner. So, the around point outside in the P channel and the around point inside in the N channel. Structure of Mesfet: self-aligner, source and drain, highly doped N-type semiconductor layers serve as the source and drain terminal. The source and drain constitute the ultimate contact, and a Schottky contact is created between those two terminals, known as aligners, source and drain. In this type, the source, drain, and gate are produced in the order. As a result, only a portion of the channel is covered by the gate, which does not span the entire channel. VI characteristic of Mesfet: the drain current resists linearly as the source drain voltage is applied, and when the voltage is increased further, it approaches the saturation area where it becomes practically constant. The breadth of the depletion region grows as the negative gate voltage is raised, reaching a piece of condition when no current or very little current flows and the flow of current is completely halted. The most current flow when the gate voltage is zero. Advantage and disadvantage of Mesfet. First, advantage of Mesfet: used in microwave circuit and operators at high frequency. The mobility of electron in gas is much higher than in silicon, and the channel lengths are shorter in Mesfet. So, the operators at highest frequencies of about 1 to 10. High input dependent lack of oxided track in thin non-oxided layer, high level of geometry control. Disadvantage of Mesfet: the turn on voltage for gas Schottky diode is 1.7 volt, so the threshold voltage should be lower than this turn on voltage. It is difficult to manufacture circuit in this range.